Hello everyone. We are here to represent Silver Bells Public School in the ViksitBharat Buildathon. We have an amazing idea for the Buildathon. And today, let me present you the team who will display this wonderful idea to you. We have Dhruv Bhatt, Diya Shah, Neerav Gupta, Vidit Badheka, Haripriya Dhamelia and Kiran Gupta as our team members. And now, let me pass on to my friend who will present you the idea.
As we all know, India faces a lot of economical and technological problems in modern day farming, which results in reduced efficiency and crop yield. Some activities like sowing, plowing, and irrigation require a lot of physical labor. Sometimes it becomes difficult to detect soil impurities and manage pests, and it also takes a lot of time and effort for the same. Monitoring all these processes at the same time becomes difficult. These issues compels us to design a robot which is smarter, automated and gives efficiency in work. As my friend has explained the current problem that we are facing today, we have designed a robot that would help in agriculture named AgroBot. Uh, it would begin by preparing the soil for planting, followed by dispersing the seeds through a vent which is at the base, and it would also analyze the seeds and the soil quality through a scanner which is placed on the top. It would and then when it would return back to the power station, it would display the analysis of the whole soil quality and seed on the screen placed on the top of the robot, and according to the analysis it would then begin by sprinkling the water which are connected to the robot.
So, as my friend previously introduced you to the AgroBot, I would like to give you a brief overview of the design. So, our AgroBot is designed as compact cuboidal robot optimized to conquer the field labor. So, going structurally, we have two chains of wheels on the sides which would help it to navigate on wet soily surfaces and rough areas on the field. Now, we have motion detectors on all four sides which would navigate its way to the field, and it also has obstacle detection which would detect any obstacle and change its path. Now, talking about the bottom, we would have three things there. First, the soil scanner which would be in the center. Second, the soil glass which would be at the front, and at the back it would be the seed dispenser. Let me give you a funny example of a football field. So now here, imagine this is the bottom of the robot. This is the soil scanner in the between. This as the soil glass on the front which would plow, and this as the seed dispenser will dispense the seed inside.
Now, as my friend gave you a great overview of the design from the outside, yet he missed some points and let me cover it. This panel right here you see would consist of micro cameras that would help it to navigate even better. And there would be a display on the top right here at this panel which would display all the data and information that are useful to the farmer. Now, I'd like to give you a very detailed and brief context of what's inside the robot. Inside this main cuboidal body, there's three main compartments. The first one being for the seeds. There would be a seed storage compartment that would be right above the seed dispenser, and when needed it would drop the seeds to the dispenser. Second one being the brain of the robot, and which powers up everything that's going on, would be the battery and the command area. It would have a battery which would power the whole robot, and then it would have the CPU and GPU that would guide the robot through its life. The next compartment being the drone compartment. But it's quite a detachable compartment because when it's back to its charging station, it would deploy the drone up, and then the drone here itself is quite optimized. It would have a small port at the bottom which is again detachable, and you could attach a container of weedicides and pesticides which would then go through the vessel pipes right here and then sprinkle off all the weedicides and pesticides through the arms.
So now I'm going to tell you about the work distribution that the AgroBot and the farmer shares. So the pie chart here shows it. The 25% which is the seed dispensing and plowing is done by the AgroBot. The 20% is the irrigation which is done by the help of the water sprinklers. the 10% which is the sprinkling over the pesticides by the help of the drone. The 15% is the soil scanning and scanning the help of the plant and displaying it on the display panel. The shades of the purple are the things that AgroBot will do, which is 70%, and the 30% other work is to be done by the farmer. The 12% is the final harvesting that is done while the crops are grown. The 8% here is maintaining the robot and refilling the charging station. The 10% is the initial point which is done before activating the AgroBot.
Now, I'd like to take over my friend and explain you the workflow of our robot. As he explained you that the 70%, which is a major part of the farming labor, is being done by the robot and only 30% remains to the farmer, now I'd like to tell you how it all actually works. It starts off by activating the robot that will find its way through the field and find the areas where it has to be plowed and planted the seeds. It will start to loosen the soil, and then by controlling the sprinklers, it will start the irrigation altogether while dispensing the seeds from the bottom dispensers that it has in it. After doing so, right simultaneously, it will check the quality of the soil and the seeds altogether. Then, if there are any malfunctions found, it would directly update its data and then on represent it to the farmer later. It will display all the data available on there to the farmer when it gets back to its charging station. It would find its way through the field after all the farming is done, and then it would attach it to its charging station, start charging itself all automatically, and then it would deploy a drone attached with pesticides and weedicides that would go on to sprinkle.
The AgroBot is designed in a way that it gets recharged and restored automatically, ensuring continuous field operation. It returns to a charging and refilling station where it connects to built-in ports to charge and restock simultaneously. This smart system saves time, reduces manual work, and ensures a continuous field operation without constant human supervision.
The AgroBot uses advanced technological tools like motion sensors, soil scanners, data processors, and irrigation tools. The motion sensors installed in it will detect the motion of the robot. The soil scanner will scan the soil and identify if there is any disease or impurities or lack of nutrients in the soil. The soil plow, which is installed at the base, would plow the soil and prepare it for planting. The seed dispensers would plant the seeds at proper placing and without overlapping the seeds. For irrigation, the robot is connected to the water sprinklers and by the Bluetooth system. For data processors would monitor the work done by the robot and would also display the scanning done by the soil scanners.
The AgroBot aims to make farming smarter and more sustainable by automating tasks like preparing soil, planting, irrigation, and spraying. In the future, it can be upgraded with AI-based weather prediction, renewable energy, etc. It helps farmers save time, reduce waste, and increase productivity for a better tomorrow. With our agricultural robot, we aim to bridge the gap between tradition and technology, empowering farmers to achieve a higher productivity and build a better future for agriculture. Thank you.